today's numerical is rectangular section of a beam 100 mm wide and 200 mm deep. If the maximum bending stress is 80 MPa, determine total force on the shaded area, maximum, and second, moment of this force about neutral axis. See this rectangular cross section with width 100 mm, total depth 200 mm, and this top shaded area 50 mm by 50 mm. And this stress diagram for this rectangular cross section. We have to find total force on the shaded area and second, moment of this force about neutral axis. Width denoted as B 100 mm, depth as small d 200 mm. Maximum bending stress, this top compressive bending stress 80 MPa, sigma c. That means this bending stress is not greater than 80 MPa. This is the maximum limit for this bending stress. And to find total force on the shaded area, F, and second, moment of this force about neutral axis, moment. So first, to find total force on this shaded area. So for finding total force on this shaded area, we use formula stress is equal to load upon area. So total force on shaded area is equal to average stress. This total force, let us assume this as P, is sigma into A. Sigma is average stress multiplied by area. This P load, that means this is the F. Let us assume this as a force upon area or pressure upon area. This is F. Because in numerical, first to find V, this is the F. So this F is equal to sigma into A here. Why this average stress we take? Because here, see, in stress distribution diagram, 80 MPa plus 40 MPa divided by 2 is average stress. Equal to 80 plus 40 divided by 2 into area. Which area? Area for that square shaded portion, 50 multiplied by 50. Calculate it. 80 plus 40 divided by 2 plus 50 multiplied by 50 is 60 multiplied by 50 multiplied by 50. 150 into 10 raised to 3 Newton. This is your total force. Now next we have to find moment about neutral axis. For finding moment about neutral axis, we use m by I is equal to sigma by y, Flexner formula. Now we have sigma, this 80 MPa, we have y, this 100 mm. We have to find moment of inertia. So find moment of inertia about this square neutral axis. So moment of inertia I is equal to about this square neutral axis, that means something here, and our original neutral axis is this. So this square moment of inertia is 50 raised to 4 divided by 12. Plus area for that square 50 into 50, 2500, multiply by, use parallel axis theorem here, between this neutral axis and this square neutral axis distance, this distance is, this much total distance is from neutral axis to top of compression fiber distance is 100. 100 minus this distance 50 by 2, that means 25 distance. 100 minus 25 is 75 mm. So this distance is 75 mm. That means this 75 mm square. This moment of inertia is equal to 14.58 into 10 raised to 6 Newton mm. 14.58 kilonewton meter. Now using Flexner formula, m by I is equal to sigma by y. M is equal to sigma by y into I. This maximum sigma is 80 MPa and y is 100 mm. This y is 200 by 200 mm and maximum sigma 80 MPa. That means this 80 divided by 100 multiplied by 14.58 into 10 raised to 6. This value is in Newton mm. So movement is equal to 80 multiplied by 14.58 into 10 raised to 6 divided by 100. 11.66 Newton mm. 11.66 into 10 raised to 6 Newton mm. And this moment is in kilonewton, 11.66 kilonewton meter. So Once again see this numerical. Rectangular section of a beam 100 mm wide. This width is 100 mm and 200 mm deep. This depth 200 mm for that rectangular section. If the maximum bending stress is 80 MPa, for that rectangular section, maximum bending compressive stress is 80 MPa. And we have to determine total force on that shaded area. That shaded area, total force. Calculate total force for that shaded area. And second, moment of this force about neutral axis. So we consider sigma is equal to F by A equation for solving total force on that shaded area. Now total force on that shaded area is equal to average stress multiplied by area. Average stress is this 80 plus 40 divided by 2. That means something here 100, 80 plus 40 divided by 2, 60 mm here, 60 mm. This is average stress, and average stress multiplied by area, that square area, shaded square area, 50 multiplied by 50, and we find total force on shaded area is 150 multiplied by 10 raised to 3 Newton. Now next, for finding moment about that, moment of this force about neutral axis. So for finding moment of this force about neutral axis, we require moment of inertia. So we find moment of inertia for that square part, 50 raised to 4 divided by 12 plus 2500 into 75 square. So moment of inertia we get 14.58 kilonewton meter. And using Flexner formula, we find moment about neutral axis. Moment about neutral axis is 11.66 kilonewton meter. Thank you very much.